Hello everyone. So today we'll see indefinite integrals. So basically, let me define first. We will focus. So the target is today integration 1 over x dx equals to ln of absolute value of x plus constant. We'll see the proof why this is true. So before do this, first we'll give the definition of indefinite integral. So here the definition. Suppose f is a function from I to R, where I is an interval if there exists a function g, so let's say from I to R, such that g is differentiable on I, and the derivative. So this is nothing but g just x is nothing but ddx of gx. Derivative of x at x is the function fx for all x in I. Then g is called an antiderivative of f. Here note so here note note that if g is an antiderivative of f, then gx plus any constant c is also an antiderivative of fx. So why this is? Because of this, we know derivative of ddx of gx. So to check this is antiderivative of fx, we need to check derivative of this function is the function fx. So this is nothing but we know the derivative operator is linear. So ddx of gx, ddx of constant. So this is fx because of this. G is the antiderivative of f, and we know derivative of constant 0. So we are getting fx. So here something I am going to write here the notation. So if gx is an antiderivative of fx on the interval I, then we will write integration fx dx is basically gx plus constant, and this is true. So so whenever we will write integration fx dx equal to gx, we'll understand the derivative of gx plus is fx on interval I. So that is very important. So if we here we will focus this left hand side. So we are given fx and we want to find a function gx on a particular interval where the derivative of that function gx is the function fx. Then integration fx dx will be the function gx. Okay, so let's do it for the function fx. We are taking 1 over x. So so this is, we can take as an example fx equal to 1 over x. So this function, if we take this function, then this function is everywhere continuous except origin. So firstly note f is defined it on negative infinity to infinity, every real number except 0, so minus 0. And also this is continuous. So yeah, it is not needed here. So but yeah, fine. So this is defined on every real number except 0. So now the thing here that so firstly the function is defined everywhere except the origin. So we can think we have the real line x and x test, and here the origin, let's say here at this point the function is not defined at fx. So if we want to calculate the integration for this function, so two things we need to consider. One thing is that to the right side of origin and to the left side of origin. So firstly, if we asked the question, what is the integration of 1 over x dx? So what it will be, if it is gx, let's say gx on 0 to infinity, we are taking to the right side. So this means this is equivalently saying that find a function gx on 0 to infinity whose derivative will be 1 over x on 0 to infinity. And we know from the derivative that the derivative of ln x is a well-defined function if x is positive. So on 0 to infinity, well-defined function and differential function, which derivative is 1 over x. So what we are getting? So we are getting that integration of 1 over x dx, it is nothing but ln x if x is between 0 to infinity on this interval. The indefinite integral of 1 over x is ln x. Now let's focus on the now suppose we are considering the left hand side, so negative number. So now integration of 1 over x dx, we want to say, let's say hx on 0 to, so let's say it will be from negative infinity up to 0. So x is now negative number. So this is equivalently saying calculate h whose derivative, this function derivative is the function 1 over x on negative infinity up to 0. So but see, we know that if we take the function ln x, we cannot take ln x because x is negative. So if we put here negative x, and if we take derivative, what it will be? If we apply chain rule, then it will be 1 by negative x into negative 1. So this is 1 by x. This is on the interval negative infinity to 0. So what we are getting? We are getting basically integration of 1 over x dx is nothing but ln of negative x if x is between negative infinity to 0. This is very important. So here we are getting very interesting thing that the integration of 1 over x, this is, we will take ln of x if x is between 0 to infinity, if x is positive, and ln of minus x if x is negative infinity. So if we take x belong to negative infinity to 0, which one we take, it depends on the initial condition. So So if you want to calculate the integration 1 over x dx, so when you will solve the differential equation, this kind of situation we can see. So we need to, so all together, you know, absolute value function, how defined it is definition, it will be x if x is positive or 0, and negative x if x is negative. So using absolute value, we can write d 1 over x dx equal to ln of absolute value of x. So this one, and where x is in the interval r minus 0. So which one we take, this one or this one? It depends on the situation. You know, if you have a differential equation and if you want to solve it, then this time you need to take which one. So let us see example, then you understand. So solve the following differential equation. So we have, let's say, dy dx equal to y by x. So where the initial condition given y of 2 equal to, let's say, -3. Now clearly here x, so we want to check the, we want to calculate the solution of this differential equation near 2 comma -3. So basically we are here, so 2 here and -3. So this is 2 somehow, and this is -3 height. So x is here basically positive. So near this point we want to calculate the solution. So this means x is positive 2. So but y is negative. So near -3. So this something like this. We want to solve it. So how do we do this? So basically we will know the separation we can use. So dy over dy, d over y. So this, if we take integration, now the question we have here, integration of 1 over y dy. So which formula will apply? Because as we see here, that integration of 1 over x will be this if x positive, and this if x is negative. So here, since y positive, so we need to take ln of y negative, so we need to take ln of negative y. Since x positive, so we need to take here ln of x, then plus constant. So why we took here this, since y negative and x is positive. So this formula we use. So basically from here you will get, if you take e, so negative y equal to, you will get e to the power ln x and e to the power constant. So we'll get basically y equal to negative a of x, right? Where a equal to nothing but e to the power constants. This is again a constant. So now they apply this situation. So what you get? So then -3 equal to negative a into 2. So we'll get a equal to 3 over 2. So we're getting y equal to -3 over 2 of x. All right, so this is the solution for this differential equation, at least here. You know, this is a line passing through this point. So okay, so this way we can solve. So something passing through this point, and maybe this way. It is a curved line. Thank you.